Hello, SAP community. Welcome to second week of the Oktoberfest 2025. Last week, we had quite a good number of sessions related to various technologies, and today being Monday is dedicated to ABAP. I'm sure you're watching the session, learning from it, completing the tutorials, earning points, and also having some fun in our Fun Friday activities like the scavenger hunt. Today's topic is SAP BTP ABAP Environment, how to monitor and support custom cloud apps. You can post your questions in the chat, and our expert speaker, Stefan, will address the questions. The speakers for today's session are Frank Jens and Richard Scholz. Welcome to the session, Frank and Richard, and it's all yours now.
Yeah, hello and welcome to our today's Devtoberfest session. My name is Frank Jentsch. I'm working at SAP in the BTP ABAP development area, and I'm leading the product SAP BTP ABAP Environment. In this session, I'm joined by my colleague Richard Scholz. Richard, could you please introduce yourself?
Of course. Also a warm welcome from my side. Hello, everybody. My name is Richard Scholz. I am an associate developer for the Technical Monitoring and Observability team, also working for the ABAP Business Technology Platform.
Thanks, Richard. So the title of our today's session is SAP BTP ABAP Environment, how to monitor and support custom cloud apps. Let us take a look into the agenda of today's sessions. I would like to start with a short overview and providing product news. So the main topic is, of course, monitor and support custom cloud apps. I will start with observability roles. And then first topic in this kind of tools is the Cloud ALM. And then I will hand over to Richard for the system local observability. And Richard will also show us the outlook for the next release. And at the end of the session, we will have our Q&A. So now let's jump into the overview. I would like to set the stage a bit that you know what we are talking about. So on which part of the SAP product universe we are. So I would like to start with the extensibility portfolio for S4 HANA Cloud. So we have here now a new umbrella, which is called SAP Build. And SAP Build comprises all the different extensibility options which we have. So on the left-hand side, we have the so-called on-stack extensibility. So this is the extensibility within the S4 HANA system. Here we have key user extensibility and developer extensibility. And on the right-hand side, here we have the side-by-side extensibility, also with low-code and key user tools. And we have also on the right-hand side, the developer extensibility, where we offer two options. One is SAP Build Code, and the other one is SAP BTP ABAP Environment. And this is exactly the product what we are talking about now. So SAP BTP ABAP Environment. You might notice the term Steampunk in the slide, previous slide. So Steampunk is nothing else than another project name for SAP BTP ABAP Environment. I'm using also Steampunk because it's simply shorter. All right, so SAP BTP ABAP Environment is the front runner for our ABAP Cloud technologies. We are providing an infrastructure which is scalable, resilient, and it is SAP managed. I would like to highlight that we have an upgrade stable approach due to the ABAP Cloud development model, which is part of Steampunk. With ABAP Cloud, we are also supporting GenAI, and ABAP Cloud within Steampunk is fully clean core compliant. So there is no other option besides using ABAP Cloud, and this is 100% clean core. So the whole infrastructure is running on Gardener and Kubernetes, so it means we can make use of elasticity And this is also a good reason with all these optimizations of the ABAP Cloud development model. All right, so it's a product like other products on BTP. It's a BTP service. In the Discovery Center, you can find all the information about the supported service plans, about our shared trial and free tier offering, and also the prices and metrics. We are supporting 4 different target groups. So we are positioning Steampunk for education. So this mainly focuses on the education part with the trial offering, so with shared trial and free tier. And then we have our 2 important external target groups, so customers and partners. So customers want to build side-by-side applications for S/4HANA. And partners do have completely different use cases because they want to build solutions and sell these solutions to their end customers, and therefore multi-tenancy plays a big role for partners. And last but not least, Steampunk is also used for other SAP products, so for products which are on SAP's price list. And at the moment, there are 5 different products on SAP's price list running on Steampunk. So before we move on to the observability topic, I would like to mention one of the new achievements of our new features which we are providing. So we are now also supporting yet another hyperscaler. So this is SAP itself. So as Steampunk runs now also on SAP Cloud infrastructure. And here we are supporting now the first data center, which is in Frankfurt. And at the same time, it's also EU access compliant. All right, so now let's move on to the topic monitor and support custom cloud apps. I would like to explain, first of all, the different observability roles. So regarding the different observability roles, we have, first of all, a central observability, and the second part is a local observability. So the central observability means that the data is highly aggregated, and this kind of observability is always on. So it's always enabled, and data is always collected. The second part, so which is the local root cause for the local root cause analysis, which is mostly a local observability. So here, this kind of monitoring needs to be switched on, specifically in order to do some performance measurement or some kind of other analysis. And here we are talking about fine granular data. So the local root cause analysis will be demoed later on by Richard, and I would like now to start with central observability. By the way, there's also yet another kind of observability with regard to the persona. So there's also, of course, a central observability done by SAP itself. So because we are responsible to operate the whole landscape, so therefore it's of course in our responsibility to make sure that the systems are up and running. And this is the right-hand side, the central observability. All right, so looking on the left-hand side, so the central observability, and here we have a central tool, a recommended tool, which is SAP Cloud ALM. ALM stands for Application Lifecycle Management, in short, also CALM. And here I would like to explain the recommendations, what we recommend, because Steampunk is used to build custom apps, either for customers or for partners. And therefore, if it comes to productive scenarios, it's very important that you as a customer or as a partner will set up central observability, that at least some basic metrics are really measured, for example, the availability and the free resources of the HANA database. So, but let's get started with the general recommendations. So, first of all, independent of the observability, it's very important to configure the systems in the right way. So, and if you provision and configure your productive systems, it's important to set the parameter is development allows to false, because it means that there, yeah, as the parameter says that there's no development allowed. That's one thing, and it protects also the development objects against direct changes via ADT in a development environment. But it also means that another upgrade procedure can be used, which is our so-called downtime optimized upgrade and updates procedure. And another thing which is very important, please use at least 4 HANA compute units. So this is our metric for the sizing of a system. So the initial or the minimum system size is only 2 HANA compute units, and we recommend for productive systems to use at least 4, because 4 gives you also a bit more buffer for the HANA operations, and also a good starting point that your data is growing. So, but in order to monitor these the free HANA memory, we highly recommend to use SAP Cloud ALM. And the good thing is there's no additional license required. You can find more details about the licensing and how it is included, and even how you can get a new Calm tenant is explained in this link here in this slide. All right, so how you can configure Calm from a Steampunk perspective. So of course you need to start creating the Calm tenant, and this is then your central entry point for Calm. And you can then configure your systems, for example, your three systems of your system landscape, or if you have a 5 system landscape, you can configure all the Steampunk systems towards this Calm instance. And how does it work? So per Steampunk system, you need to create a communication system in the admin Fiori Launchpad. And this communication system represents the endpoint of the Calm instance. And then based on this communication system, you need to create a communication arrangement based on this SAP pre-delivered communication scenario with number 527. So, and here you will do all the settings, and this creates the connectivity from the Steampunk system to the Calm instance. And with this approach, alerts and those things and the metrics can be pushed from the Steampunk system to the Calm instance. You can find more details how to set up this connectivity in the tutorial and also in the Calm documentation. All right, so what are our observability recommendations for productive systems? So our integration from Steampunk into Calm comes with a lot of metrics and a lot of characteristics which can be measured. But I would like to highlight, from my perspective, the 2 important ones, which is the ABAP compute units and the HANA compute units. So just remember, so Steampunk provides 2 important metrics how to size a system. So this is basically the number of gigabyte of the ABAP application memory, and the second thing is the size of the HANA memory. So both is configured in blocks of 16 gigabyte. And the initial size for ABAP compute units is 1. So it means a typical system has 1 block of 16 gigabyte ABAP memory. So for the HANA part, as I mentioned, the minimum size is 2, but the recommendation for productive systems is 4. And here it means also one block of 16 gigabytes. So 4 blocks of 16 gigabyte means 64 gigabyte HANA memory. So the recommendation is to configure alerts with a threshold of 80% to create to start with a warning, and then to configure 95%, for example, for a critical error message. So, and these are the at least the recommended minimum alerts. So there are much more also regarding short dumps and so on. But I would like to show you in the system now how it works. So therefore, what I already did, I have an running Calm instance. So this was prepared. So now I have my landing page of my Calm tenant. And in order to do the health monitoring, I navigate to operations and health monitoring. And I already configured my system. I have one Steampunk system with the ID GA5. And I can navigate into the details, into the different metrics, which are automatically provided by Steampunk. So if you are doing the configuration, so you are getting these different metrics. So for example, the ABAP runtime errors, you can also define an alerting based on short dumps. But the important thing, what I would like to show you is the ABAP compute units and also the HANA compute units. And as I said, this system is configured with one ABAP compute unit. This is also visualized here. And the HANA compute units in this system is 4. So, and 0.41 means that that this one ABAP compute units is 0.41 is currently used. So this metric calculation is based on a 5 minutes time frame. So now I would like to show you how you can configure your alerts. So you can also do the you can also show the history. So I created a bit load in that system yesterday evening, but this system is not heavily used currently. And what I can do is I can do defining alerts. So here I have my metric overview. Here I can define the threshold, and here I can define the events for the alerting. So I can specify that I'm getting an email notification once this alert, this threshold is reached. So here I can configure who should receive an email and whether it's email or not. And yeah, that's basically the configuration. And if I just for demo purposes, I reconfigured this threshold yesterday evening to get a notification only if it exceeds 0.4 ACUs, and this leads to a notification like this one. So that notification from Calm, and the message was it was a warning because I exceeded the 0.4 threshold. This was only for testing purposes, and then I was notified with this email. There are also other possibilities. As I mentioned, you can also get informed by core dumps, for example, if there are core dumps. So then you can also receive error messages. So I try to get an out of memory for the current session. So this was a short dump. No, this was the warning, because it was not really a short dump. So the session was not stopped. This was only a warning about memory exceeded an internal threshold of the session. And this was a real out of memory short dump. All right, so this is what I wanted to show you. It's about SAP Cloud ALM and how you should configure it, at least for your productive scenarios, in order to make sure that for example, your HANA database is not running out of memory. So if you would receive such an alert, then you have, of course, the option to increase the HANA memory via the BTP cockpit. So this is a self-service where you can increase the sizing of both, so the HANA compute units, but also the ABAP compute units. And this alerting is a very important thing, that you be informed about such exceeding memory thresholds. So with that, I'm at the end of the central observability part, and I would like to hand over now to Richard.
All right, thank you. Let me quickly take over the share. So should now be able to see the PowerPoint again. So I'm not going to show too many slides, so only just a quick going back to the previously slide that Frank already showed, but now it's a little focus on the local root cause analysis. So basically we have three main stacks. The first one is a Fiori Launchpad, where we have our Fiori applications like the Technical Monitoring Cockpit, HANA Sweat Samples, and many more. And on the other side, we have the ABAP development tools, mainly our IDEs like the ADT, where you can have some plugins and then can interact with our landscape. And at the end, we have the VS Code plugins. They're only one, which is the HANA SQL Analyzer, that can be utilized as well within our technical monitoring environment. So now I'm going to focus on the Fiori Launchpad applications. So later on, maybe how this interacts with the other ones, like the tools or the plugin, I will also show you. But of course, you want to see some hands-on what you can do with our applications and how you can access them. So I'm going to stop the PowerPoint now and directly go into the browser. So first things first, as always, you require some permissions to access our applications. So a lot of what we are doing is like very technical and not maybe for everybody, but if you want to access them, you require some roles. So in my case, I have a business user within the GA5 system that Frank already showed you. I have a developer. This is because I also published an application that we're going to use as an example. But what I need to see the applications is actually the administrator. In this case, it's generated by our template that we provide to you. But if you have your own roles, which is of course encouraged, you will have to check that within your role, you have one specific business catalog. Let the data load for a second. And now we're going to down. So the name already says it. It's a technical monitoring catalog, shorts SAP Core BCTMC. So if you have this business catalog assigned to your role, you will be able to access our applications. So then we can move into the Fiori Launchpad. Our applications are located under administration, but under technical monitoring. Let's jump into that one. Perfect. Now we're here. So as you can see, we have quite a lot of apps that are separated into four main columns. The system analysis, which contains the majority of our applications, the application jobs, the output management, and of course the tools. And the tools also strongly interact with our applications. So as you can see, it's quite a lot. For those who are not familiar with Fiori, basically each tile represents one application. So you see we have quite a lot of apps. I'm not able to show you everything, But of course, feel free to try it out if you have a system or you get a trial account to play a little bit around with these applications. So what do we have? First of all, of course, ABAP runtime errors, similar to what Frank already showed you. There you are able to actually analyze the dumps that are created within your system. We have the communication, of course, and something that I want to highlight, 3 new apps that we just recently redid in a brand new Fiori style, which is the SQL statement analysis, the HANA table analysis, and the HANA memory analysis. The SQL analysis, the name already states, is basically for you to analyze the different statements that are fired within your system, especially the ones that are important, like the ones that are used very frequently or are very expensive. The HANA table analysis shows you how much memory the tables within your system are consuming. And the HANA memory also looking at the memory consumption, but here dividing it into the different components that you have in the system, like row tables, column tables, or the SQL plant cache, for instance. So no further ado, let's directly jump into one of the most powerful applications that we have, which is the system workload. So the system workload is actually one of the views that we have within our technical monitoring cockpit. If I open this one, you can see we have a lot of different views here. But now let's take a look at this one. So what are we seeing? First of all, most of our applications provide you with like a time slider. So you can always select the time range that you want to take a closer look at, mostly configured to the last 24 hours. And something additionally is the granularity, which is also provided by most of our applications that you can actually decide, okay, we always look at a lot of data, but how do I want to display this data? This is like every 10 minutes and hours or even days if I look at broader time selections. Our newer Fiori applications don't directly provide this time slider, but rather a time selection like this one, where you can still configure your time selection. So, of course, we have some filters. I'm going to skip these for now and directly jump into the data. So what are we seeing here? This is basically a stacked column chart that is distributed over the time selection that we initially set. The metrics that you can see down here, to sum it up, if you add up each of these metrics for every request, this is the total time a request, for instance, from a Fiori application, going back to the backend, to the HANA takes. So we have HANA preparation time, execution time, network times, and a few more. Of course, all of these are important, especially like in queue times or hold times, where we try to keep them very low. But like Frank previously mentioned, 2 key driving factors are first the HANA execution time, which you can see here. So this is the time your request to the backend takes within the HANA. So this is mostly the SQL statement that is then executed to retrieve you some data and give it back to your front end. And another really important one is then the ABAP processing time, which is the time your request takes within your ABAP code. So both of them are quite important because this is also the way where you can improve. So if you try to reduce or optimize these times, this will significantly also reflect in the total execution time. So this represents like generally what is going on in your system. This represents all the requests. And what are we seeing down here? So this is now the top workload. These are based on the ABAP statistic records. So for you who don't know these records, an ABAP statistic records is basically capturing all the information you need, like the times that you can see here, as well as context information if you send a request to the server. So this is really a very detailed and granular way to see, okay, what is actually happening in my request. We do not capture this for everything. So as you can see, this is only the top workload. So the one that we think is important for you, which maybe break some thresholds or have some like outlier behavior. As you can see, we have some request entry types, so some batch jobs or some URLs, and also the request entry name, as well as the different time that took, as well as some REST aggregations here. So, but of course, if you develop your own cloud app, you want to see how is this app is performing. Of course, knowing what is my system generally doing is quite interesting, especially for analysis. But now I'm a developer. I just want to take a look at my app. And for that, we can now go to the filters that we have. I think the most important one there is, of course, the request entry type. So what kind of app I'm deploying. In my case, I deployed an application that we can see here. It's a classical flight travels app. I deployed it now in the system, and now I want to analyze it. If I put this a little bit away and press go, then I'm filing a request, and now I want to see how is my app actually performing. To see that, first of all, let's filter for data v4. In my case, I know it's a v4 application, and then I directly see it. Okay, in this case, my application is not under the top performers. And this is actually something that can happen. So if my app maybe is like a very small one, it does not break any threshold, it might happen that it's not captured here. So a second thing I can do, if I know the endpoint name, I can also filter for that one. So in my case, it's SAP OData and then the name of the application. And now I see here actually like some request captured. And one thing I want to show you before I take a look for my specific application, let's remove these filters real quick. Something also generally you can do, which I now skipped previously, are these views. Because currently I'm only looking at the response time contribution of the different metrics that we show here. But you can also take a look, let's say, only at the HANA processing time. Let the data load for a bit, and now we basically have a different view to look at our applications. Again, we have our sample data here, but we also have a drill down. So currently we are requesting for the entry type. So again, the protocols like OData v4 to v2. If I remove this one and then take a look at the request entry name, let it load a bit. And then again, I see the different applications that I now have over my time range and how much processing time on the HANA they're actually consuming. Let's take a look. Do I also find my app? Yes, perfectly. Here is it. Quite a small contributor, but still, of course, it's there. So it's generating some load. So now going back to the initial view, to the response time contribution, filtering again for my application. I get my top workloads, and then let's jump into one. So again, I see the distribution over my time selection and a lot of requests here. Because I already played around a bit with the application, the system already captured quite a few ABAP statistic records. So each row that you see here represents now one captured statistics record. So we see, okay, we actually have quite a distribution. Some are quite long, while others seem quite fast, but still everything over 1 second is in our context actually quite a long time. So let's take a look. We can even move further, and then we are actually within the ABAP statistics record. And something we directly see here is now we have a huge amount for all of the different steps the request undergoes. The HANA execution time is very dominating. Why is that? For me now, I built a little hiccup within my application that does a check that maybe is not the best way of doing something. So of course, every application, so it's difficult. If you have application that sums up a lot of data in the background, does many joins, for instance, of course, it will take a long time. But also with smaller applications that generally maybe do only smaller queries, so they're generally faster, but still there might be potential to optimize this. Especially in my case now, due to the small error within the query where I do maybe like not an optimized way of filtering my data, I can see this directly impacts my requests and makes the whole request quite slow. So on the right time, again, you see the data that you see on the left in a tabular way. Again, okay, the HANA execution time very dominating in this case. Let's take a look at the SQL statements, because if I know it's HANA processing, threshold or like this is a problem, like something on the HANA is happening, it's most likely related to the SQL statements. And if I take a look at the statements, I directly see, okay, this one especially is consuming a lot of time, a lot of CPU time, and also memory. So this is very, very expensive. And I could now go to analyze the statement, but before that, I want to go one step back. So you see, these ABAP statistic records are really essential to analyze your application to see what is actually happening. But what if, like I go back now to the records, there is not too many records are captured for my application. So this might be happening if you have a very busy system, your application is very small, it's kind of suppressed by bigger ones. But now you're a developer and you really want to analyze this one application, and I want to capture statistic records, especially for my app. What can I do now? And for this, we have one tool that we now can take a look at. And also, while showing you that, also showing how are the other ABAP statistic records within my system actually captured. So let's go back to our technical monitoring, and now we move to tools, especially to the capture request statistics application. So what are we seeing here? So we have different profiles. In this case, all of these are like ABAP statistic records, profiles, and all of them, which start with a SAP prefix, are records that we as SAP provide to you. So yeah, they're always running, they're always directly within your system, and these profiles are actually responsible for capturing the workload that we see in the system workload application. Let's take a look at one. This one is the expensive request regarding the HANA CPU time. Again, the profile type, ABAP statistic records, user group, the customer, and the owner is SAP in this case. The start and end time is set, but of course it should be running indefinitely and should always be in a state of processing. As you can see, this one is a quite simple threshold filter. So we say if the time is longer than 1 second, keep in mind this is in milliseconds, then please write this request away and store it as a statistic record. Also, we have some retention times in this case 2 weeks, 50 records per minute, and a sampling rate of 1%. So so let's say first, the other ones are quite similar. So they always look for different thresholds for the important metrics that we have. But one really cool thing we also utilize is a SAP dynamic capturing. So this is not only capturing raw thresholds, but kind of tries to get a feeling for the application. So of course it's difficult to compare a huge application with a very small one. So what this dynamic capturing is doing, it kind of calculates the average consumption of your application and then checks, okay, do I have some outliers? So also this prevents that the bigger applications in your system will always suppress the smaller ones. Okay, but all of this does not ensure that I'm capturing everything from my own application. What I can do now is I can create my own profile. Let's call it DevTober capturing. And it's also an ABAP statistic records, and the user group is the customer. So this cool flag, also something quite nice. This would allow you to send this information directly to Calm, what Frank previously showed. So if I define some metrics here, I could also utilize this data later on within my Calm dashboard, where I can now then utilize like the communications, send some mails, all the nice stuff that Frank already showed. All right, let's create this profile. So initially, of course, it's inactive. I also need to define a condition. Let's create this one. I have again quite a lot of different fields that I could filter from. In our case, the request entry name, which is the name of my application, then include equal to. Let me quickly copy the name, and then we put it here, and we create it. So now this profile is looking for all of the requests that are hitting this endpoint, so my application. One thing or one last thing is the local store. For this one, we go into the edit mode, say, okay, it's not that important, maybe like 1 day should be fine. A record limit of 100 records per minute and a sampling rate. This is now quite important of 100%. This means I'm trying to capture every request that goes to my endpoint, to my backend, to my server, while of course taking into account the record limit per minute. Now I can save it and then I would be able to activate it. Of course, the duration, we do not want to have many profiles running in the system uncontrolled. So you will always have to define how long am I doing this. This is quite simple. So basically, if you now want to test your application, just do it maybe for 5 minutes, activate it, and then you would trigger some requests to your server. And all of these requests will then pop up within here. So it takes, let's say, roughly or maximum 1 minute until the ABAP statistic code is written to the file system, and then it should be displayed here. All right, so now we know how we can capture the workload, especially for one application. Now let's go back into the analysis mode, assuming now we have quite a lot of ABAP statistic records for your specified application. And we already identified, okay, the problem is kinda on the HANA execution time. So something is not completely right with our SQL statement. And again, we have a lot of ways to analyze here, but first, the SQL statement. So every ABAP statistic record actually consists of multiple statements that also not only capture the data that you then would see within your test application, but also like some meta information. So everything that is required to execute your query. We see, okay, this one is actually the one that's causing most of the troubles. Let's analyze this one. So every state element in our systems are always assigned a statement hash. This one uniquely identifies the statement. Is also used in other applications because it's just also more handy if you want to analyze a specific statement. Just take this one instead of the whole statement string. And what we're seeing here, this is actually the statement that fetches the data for the different columns that we see within the test application. And here's also the little hiccup that I mentioned previously, where I have a check on the description with a like value, so a wildcard, which might not be the most efficient way to query strings. So this is most likely the reason why my HANA CPU, my HANA processing time is going through the roof. So what will I do if I now want to even further investigate? So this is still gives me a lot of information, but I want to go even deeper to understand more what is actually happening within the statement. For this, we can take the statement hash and move to the SQL statement analysis. This is one of the applications that you can also see in the Technical Monitoring catalog, where you directly see now it's all about statements. Again, the statement hash is used as a key here. We have the number of executions, again, for a time range, as I mentioned previously, and the statement string itself. So what I could do now to get some information for this specific statement, fire it up, let the data load a bit. Here is it. Now I can move to the object page. And again, I see in a nice way the statement itself. And now I can get even more information. I have the application source. So where was my statement executed? And also which plan ID was used. So HANA basically tries to optimize every statement that comes in to execute it in a way that is most efficient. And for every generated plan, how to do that, it generates a plan ID. So these plans are reused, stored within the SQL plan cache. But after some time, HANA might generate a new plan. So we'll see different plan IDs. You can also jump here into the browser to see the ABAP source code or directly have a hyperlink into the ADT. Now we can move to the metrics, give it a bit to load. perfect, that's coming up. Some general metrics, and then we see 4 always filtered for the different plan IDs. As you can see here, we have 2 plan IDs captured in this case. And then we see, okay, how often was the statement actually executed, and then how high was the total execution CPU time. Like I said, this one is one of the new applications we done completely in Fiori. And of course, Fiori gives us quite a lot of cool features, especially that you can now customize these graphs to your specific needs. So depending on what you actually want to analyze, you can take a lot of metrics into account and basically build this graph as you desire or as your specific use case requires. All right, but now the last level of analysis that you can basically dig into are the traced executions. So currently there are no items available, which will be the case for most of the statements, because this is also quite expensive. So you are able to trace the full execution of the statements. So you see directly what is happening on the HANA, how is my query actually executed? And this is the most granular, most detailed way of analysis to see how can I even improve my statements. So these files that you can then download here are called PLVs. The PLV file gets generated. I will come back to that in a second. And then you can download it here and put it into the SQL analyzer. This is one of the plugins that were initially shown within this nice overview by Frank. So finishing that, I want to move to the Outlook and then also explain you a little bit more about these PLV files. So currently you can capture these files while using the ADT. We have a nice tutorial, as you can see on the right side, how you can capture these files and then download them from the SQL statement analysis, put them into the HANA SQL Analyzer, which is maintained by our colleagues. And then you have a really nice UI to exactly see, okay, how is my data processed? And you can then see, okay, how can I actually improve my SQL statement? But the problem is now you have different mediums, so you have to jump from the Fiori Launchpad into the ADT and then into VS Code to utilize the analyzer. But with 25.11, we have one really cool new statement feature, which is also within the capture request statistics application, and we introduced one new profile type. So we have the ABAP statistic records, which I talked now a lot about, the SQL traces, which we also have, and now we also have the HANA plan trace. This is a new profile type. You can also, like I previously showed, create one, and then you can set a condition. Currently, we only support the filter of the statement hash, which is also from our point of view, the most important one. And then you can capture every statement and get really this executed plan, which you can then further analyze. And again, this is a really cool feature. We're really happy that we can deliver it on 25.11, making this whole landscape a little bit easier to navigate, and also gives the admin more freedom that he can directly stays within the Fiori Launchpad and doesn't have to move to the ADT. And with that, I'm finishing my part, and I'm now handing over to Frank.
All right. So, yeah, Shilpa, I think you will moderate the Q&A now. So we answered a lot of questions directly in the chat, but maybe we can repeat a few of them.
Yeah, maybe you have answered most of the questions. Then one question just came up now. Can Cloud ALM, let me read it out. Yes, can Cloud ALM also be used to identify unused or obsolete code or apps? So we identify objects to retire.
Yeah, good point. So Cloud ALM is not intended to do static code analysis. So static code analysis, and this is yeah, to identify unused objects. So this is yeah, more in the area of the ABAP test cockpit to do all these kind of static code analysis. So again, Cloud ALM is for monitoring observability of yeah, of different KPIs which are relevant during runtime. So it's not for the static code.
Maybe I can add. Frank, you're totally right. Answered for the BTP ABAP environment because it is a fresh new cloud deployment. If the question is related to our Cloud ERP private edition, there are other aspects so that you really can go into this custom code migration, since you really have here from product scope also lots of classic ABAP coding area. But for BTP ABAP, so it's true. Here we focus on operating the systems.
Thanks, Stefan. Other questions are answered, but maybe you can also we can also take the same questions. We can repeat it. There was two questions about do we have trial version of SAP Cloud ALM? Probably that needs to be checked, right?
Yeah, but I also think that there's the demo tenant. That's why it was created. There is no specific content for BTP ABAP environment, but it's more or less the same as for the S/4HANA systems. And it's a pure demo tenant so that you cannot connect your own trial editions to it. But Cloud ALM comes along once you have your SAP Cloud subscription, then it does not require any additional licenses. The SAP Cloud subscription already include the license for Cloud ALM.
Okay. There were two questions also about the communication setup. So where do we set up the communication instance? Can this run on dev instance, or do we need to use a dedicated one? And there was also a question about how can it be transported or not?
Yeah, the complete communication setup as of now, you cannot transport connections in the cloud environment, even when this was a feature of SM59 in the past. In cloud environments, you typically do not transport connectivity or credentials. That's why, as of today, you have to set up the connectivity from your BTP ABAP instances to Cloud ALM manually, but we are working to get this solved.
Okay. Does SAP internally have a more detailed visibility of customers' Steampunk environments? Can SAP monitor customer Steampunk?
I would not say more detailed. It's on a different level. Of course, as outlined in the picture of Frank, that there was this box that we monitor the systems. In this slide, you see that, of course, we monitor all the BTP ABAP systems from a platform perspective. So we monitor that your network connectivity in general is working, that the system is available, that we take care to monitor also HANA backups and all these things, what comes along with the platform. But what we do not do, we do not monitor the application code on the BTP ABAP environment. So there are different levels from infrastructure monitoring, platform monitoring. This is taken care by SAP. And then when it goes to application and slightly also goes into integration monitoring, how your system is connected to other systems, this is where Calm would help you to really focus on the application and integration layer, because that's something what we from SAP cannot do in general. But platform and infrastructure monitoring you get by us, and we take care to monitor these aspects.
And let me add, so there's no dedicated channel that even we would identify and that the HANA memory is fully occupied, that we cannot inform customers or partners. So therefore, as Stefan mentioned, so this application monitoring is in the responsibility of the customer or partner, and we are responsible, and this is our application for the platform itself.
There are no other questions. We have answered all the questions. I don't
Yeah,
see
maybe we can repeat this topic about what are the examples which could lead to an out of memory with regards to the database or the ABAP instance. So there are a couple of things which might require more resources. So let me start with the ABAP compute units. So this is the ABAP application server. And I think the most obvious thing which requires more or which creates more load if more users are using the system. So just imagine a customer has built a custom app and it's currently used maybe in the first phase by only 100 employees of this customer's company. And then with a next rollout, the number of users is increased over 1,000 on a daily basis. So more than 1,000 active users on a daily basis. So this increases the required number of ABAP compute units. And now the question is, with this more than 1,000, it depends a bit on your application, whether it's then 0.8 or it's more than 1. And then you need to increase the static sizing of the ABAP part. So then you need to increase the number of ABAP compute units. By the way, you can set it to two ABAP compute units, and at the same time you can switch on elasticity, which means that only if there's a bigger load in the second block of ABAP compute units is used, and then once the load is gone, then also the second block is reduced automatically. So, and with regard to the HANA database, I think this even more obvious. So if the customer data grows and grows and exceeds the static initial size of your system, then yeah, you need to increase the size, and this is really important. This is really important because sometimes it's really hard even to remove data, because also the HANA operations is endangered if that much memory is occupied. So according to the static size. So please therefore set up Cloud ALM and measure the percentage of the occupied HANA memory.
Thank you, Frank. And let's give one more minute. I don't see any new questions coming up, but this was a good interaction. We had a good session about, especially about how to understand about the complexity, how to see the CPU, how much especially the graph that you showed, and how to monitor the custom code apps and all. It was quite interesting. We just have 3 minutes. Maybe Frank, you can also share more about which are the sessions that is coming up in the TechEd as well as in the Devtoberfest. What can we look forward to?
Yes, thanks. So I would like to do a bit more advertising. So we have much more sessions about ABAP Cloud. So again, ABAP Cloud is our new development model, and ABAP Cloud is used, for example, in the Steampunk product. And today we explained a very dedicated topic, which is observability, but there is much more in this area of ABAP Cloud. So we have also more sessions about ABAP Cloud within the Devtoberfest series, and there are also, of course, more sessions as part of SAP TechEd in 2025. So with that, back to you, Shilpa.
Thank you so much, Frank, Richard, and Stefan, for this engaging session, which is quite important. And we have seen there were so many questions, and it was good that you also repeated the questions to give more detailed answers. To our participants, the link to the presentation will be put up in the description. And if you're watching replay and you still have any questions, you can also post as a comment in the community page. The validation tutorials also will be available by the end of the day, so that you can answer the question and earn points. So thank you for joining, and see you in the next session. Thank you.